Hello, I'm sorry about the audio. I have my 3D printer going in the background, so it's a bit noisy at the moment. The purpose of this was that we had a client recently who had a shower screen that wasn't sitting in location quite properly, and the clip itself isn't really sold on the market or anything like that. So we got a few measurements and everything on site to try to suit the actual location for the bracket and stuff, because it's kind of offset to like a dado rail and stuff. And the idea here is that we're just going to make up something that's not currently available in the market, sort of thing. We've had to do this a few times now, so I just thought I'd do a video showing what the process is to making custom components that can help with home maintenance, RV maintenance, any of that sort of thing. And it's relatively cheap too. So all that we're looking at here now, this is just the CAD side of it. So CAD is computer assisted design. And in this side of it, all that I'm doing here is I wanted to check the offset from the top of the shower screen to the center of the dado rail, so that we could locate the shower hanging rail to be like dead center of that freeze or dado rail or whatever it is that's running around the top of the shower there at that house. We're doing a lot of maintenance for older homes and stuff now as well too, which is so the need for custom components becomes greater, because there's some areas, some profiles, some things that aren't made for what a lot of the modern products are showing. So here you can just see we've got this over here, just represents that's our shower screen over there. This little box over here is just representing our rail that was there, that was present. And you can see there now we've got that all set up, and I'm just taking a center line from the center of that across to test what was that height between those two locations. And we get exactly 38 mil, which is good. So we want that. We want that to be, want that to stay like that, so that we can now we can just double check on that and make sure that's an ultimate number, which it is. So it's exactly 38 millimeters. I thought there'd be some sort of finite number in there, but exactly 38 millimeters. Okay. So that's good. Now that we have that all set out and we got that distance that we needed, the offset from the top of the shower screen, we can go ahead and jump straight into making a part for it. We don't really need that anymore. We only needed the 38 mil. So now we'll actually make like the shower clip itself. And the idea here is that it's a shower clip just to hold a shower rail. When I say a shower clip, it's like clipping over the glass screen to then hold a shower rail, so that a person can just have a shower curtain on the front of their glass shower area, so it's not just wide open, so to speak. And the current setup hasn't been made for any of the available rail systems that are around, mainly due to that dado rail and the way that it's meeting. You can't really have your rail sitting level in there, and at the moment they've got like a 12 mil anodized rail that's not quite working for them. Just sagging and not doing the job. So all that I'm doing here is just making up the carcass for the clip, and I'm just doing that by, there was some specific measurements that I gave myself, like I wanted it to have a 70 mil long body, I wanted it to have a 35 mil gripping onto the wall, and that I know that the rail that we use, it's sold as a 25 mil rail, but if you measure it, it's 26. So, and the machine itself has a 0.2 mil offset. So you can see there I've got the distance for that's 26.4 I've got on it, but it's a 25 mil rail, so to speak. And now that we have those specific locations, like where the rail was and where the screen's clipping in, basically all I'm doing now is just drawing in like some extra body, the body of it, something for me to extrude out to get ready for printing. I'm not doing anything fancy here either. As a matter of fact, I'm keeping it really, really simple. The main reason for that is because there's some numbers and stuff I could go over with costing of design and everything, but the CAD side of it comes down to somewhere in the range of about 81, 85 cents a minute. So, that can add up really quickly. So sometimes in this sort of case, not spending a lot of time in CAD is kind of the purpose of it, if you know what I mean, making it as simple as you can. So I really didn't sit down and think this design out beforehand. I just grabbed those measurements, and now I'm just throwing something together. There's 100 different ways that you can draw bodies inside CAD. Obviously, this is just how I'm doing it at the moment. I'm probably going to end up with a lot of features in my feature tree for this CAD design, and that's fine. And it's just the purpose of it was I'm going really quick to just try to throw something together nice and easy, because as you can imagine, basically the cost of the program is quite high. So the more that the program is used in any type of design, basically the cost of the program then is passed on to whatever it is that you're doing. And in this case, as I said, that comes down to about 85 cents a minute sort of thing. So as you can imagine, that ticks up pretty quickly, especially when you have to do design for weeks and weeks on end and stuff. So simple little stuff like this, little clips and things, really simple to throw together, and we're talking minutes in CAD. So ultimately this all up was like 10 minutes in CAD. I think if you time this video, it'll work out to be about 12 minutes 45, but if you were costing that, you'd charge that out at like 10 minutes of CAD, so $8 sort of thing, which is very affordable for people out there who want this sort of thing done. Like if you have custom things you need in your house, maybe clips that have broken, maybe older like curtain rails, shower rails, screen door fittings, many of these features that were designed by manufacturers and stuff that have now gone out of sale as they've moved on to future revisions, like their current version of the product, and maybe some of these older profiles and features that you wanted, or that can fix your current part, aren't readily available on the market, sort of thing. And 3D printing can really help get around that. And I thought I'd show this video just to show people that if you're thinking, oh, but that'd cost a fortune sort of thing. So no, it's actually super cheap, and it's very, very competitive with pre-made products on the shelf at the moment, especially in the range of just plastic printed clips and door stops and stuff like that. The cost of the PET and the ABS comes down to somewhere around about 22 cents a linear meter, and there's like 15 meters in a design this small. So there was like $3.50 or something like that in material to do this. Plus you take the CAD time into equation, like 8 minutes of CAD. There's another section for CAM after this that I'll show, but ultimately you're looking at like $12 for a prototype brand new part, custom for whatever you're doing, and $12 is very competitive even with readily made parts that are on the market at the moment. So yeah, that's why I wanted to make this video, to show people this is a very feasible option for a lot of things. And we do a lot of replacements for curtain rails and things where you just can't get that type of clip or that type of thing anymore. And I've had to do it a few times now, where it just helps people out to be able to say, hey, look, maybe you don't have to spend $55 to buy the whole new curtain rail and everything. Maybe we can just, $15 or something, and we can make up a clip that'll work sufficiently to hold your current system in place and not have to incur that further cost. My on-site trade fees are much, much more expensive than, than this CAD side of it. Obviously you've got a lot of tools, your work vehicle, time, all these things involved in that sort of stuff, whereas really in this design feature you just have to pay for the program. And my time that I charge out on the CAD side of it is, as I said, it's cheaper than my labor side of it. So like getting me on site to figure things out is actually a little bit more expensive than getting me to just sit at home and design things. I only say that because if you can send dimensions, then that helps a lot. In this case in particular, we've had to go out to the site. We took our measurements, we observed, we inspected the works and stuff like that, and judged what needed to be done. So that incurs then a little bit more cost then as well. So there you can see that's pretty much the body of the clip, everything. Just throwing these fillets on now. Fillets and chamfers are just ways to try to make it look less boxy, less square. You can sand a bit of that off if you want. It won't give me this. I want it to have the fillet up this back line here, but it won't do it. This will have something to do because I've grabbed so many features in the previous filleting. So I'll deselect this, and I bet if I start the feature again, accept this one, and then start the feature again, it'll probably let me actually go through with filleting those lines then. I will get a little round down here on these corners too, and on the back there. Just to, again, make it look less boxy, less square. The less sharp edges, the better. Yep, and we want something on that back line there. So we'll just try again with the fillet, and now it's in a separate feature. It'll probably, yeah. SolidWorks has a few little bugs and stuff, but they're pretty easy to get your head around. In this case, it just didn't want to do that certain fillet because it wasn't quite figuring out how to do it with all of the other fillets, but then in a separate fillet feature, it does it fine. Okay, and we'll just throw a little fillet on there. And what I don't show from here is all that you do after that. So we've made this component here up. Now I'm going to throw a material on it for the sake of it, but you really don't need a material on it. I can use the materials and stuff for then testing in FEA, but ultimately we don't really need that, anything like that for this. So from there, all that we do basically is that it's exported then as an STL, and in SolidWorks all I do for that is I go up and there's just another option to save it as a STL. And so in this case, we're just throwing in, we'll just save this here as shower clamp 3. Give it a little description. The descriptions I've got them linked to show up in my drawings and stuff, but I'm not making a drawing for this. And again, the CAD time is expensive, so to make up a drawing that no one's going to use then is. But there we go, that's our clamp, and then we just export it as an STL. And then we get over here into CAM, and the CAM side of this, super easy. The CAD side's the hardest bit. The CAM side is a lot cheaper because, as you can see here, it's Ultimaker Cura is the program. And that's my machine that it's got in there, the Creality CRX, and Automaker Cure is a free program ultimately that came with the machine and everything, so it's not much. This just comes down to the cost of the machine, and the working cost of this 3D printer in particular, I factored in to be somewhere at 7 cents per hour, not including material obviously, and that's factored off a lot of different things that you take into equation on these machines, included their overall expected life, the upkeep on them, the cost of the initial purchase, how much it can be salvaged for at the end of its expected working life, and all of this sort of stuff. So ultimately this machine in particular I calculated down to about 7 cents per working hour, but as well too, I factored that at a 5-year lifespan on it, which is probably very generous for what it ultimately is. It's probably got closer to about a 2-year working lifespan on it when I factor in all of its other working equations and stuff. So, but it wouldn't, even if we halve that, we'd say 14 cents a working hour, and that's still extremely, extremely good. So here you can see that's it, just all in its layers. So Cura now has taken the program and taken the STL and sliced it into this feature to show us what it's going to look like. And here we can drag down the layers of the print, and you can see internally here is this is the inner structure, which I've got that set there to 20%, but we can up the percentage of that to make that denser in its packing, and we can also change that shape from like a hashing or a crosses to like a honeycomb shape. The blue lines down the bottom there, that's basically a prop. So the 3D printer will print up, you know, some easily breakaway props and stuff like that in that blue area, just to keep it all supported as it prints up. So yeah, that'll be our print. So as you can see, the slicing side of it's super easy. It's really mostly in CAD. So here it tells us the amount that it plans to use. So, you know, it plans to use 15.57, which gives us then a cost for the material and a time for the machine. So it says it's going to be 4 hours there. So we roughly know that it's 7 cents per hour. There's 28 cents of running this machine to do that. There's $3.50 of material in trying to do that. There's let's say $10. I think it actually came out to be $8 something in CAD time. So, you know, that's where you land with your $11, $12 for a prototype brand new custom component, which I think's not too bad. So in here I'm just shortening up the name of this G-code file, because my machine in particular, if the name strings over a certain distance, then the machine will stop recognizing it. Silly CRX. So that's it for the cam side. Very, very nice and easy. So now what we'll do is we'll try to get over to the machine, and all that we've do now is like, so I've thrown in my little card. I've got a card reader for the machine and stuff. This is inside the machines. Oh no, this is just my G-codes, grabbing my G-codes. Where was it? There it is, our shower. Click 3, out of Cura. And we're going to copy him over just back to our USB drive, which is our little reader stick. Throw him in there, nice and easy. Again, that easy, really not a massive process for people who might be thinking this is a huge, I imagine whoever made these programs, that was a huge process, but thank heavens for all those people, because now we get the rewards of of this. So here's the card. You know, got the information onto the card. Card just goes up into the old printer. And we turn him on, and he says hello. And it's just as simple then as turn it on to print. Select the file, we go print. There's some temperatures there on the display, and what will happen now is the machine has to heat up to its temperatures, and then it'll begin doing its thing. So it just homes its head first, which is just homed its head into the corner. And you can see now it's going to really slowly start ticking up. It's going to get to 200 degrees Celsius on the nozzle, and the bed's got to be 60 degrees for this material. We come back a little bit later. It takes it 5-10 minutes to heat up. There you can see it's right on nozzle temperature, and as soon as it hits the 60 degrees on hotbed, you'll see the head will start, and off it goes. It actually has a little problem here for a second, you know, because it was trying to clear its head out, and it spewed a bit of gunk out, which you'll hear it go like clunk, 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 which is just it was all good, but yeah, you hear that? Anyway, when it jumps into the actual printing, that's what you were seeing before in Cura. So you can see there the layers, that's that honeycomb, or not honeycomb, that's just the hashing as its fill. Yeah, and that's just the machine. It runs its G-code now. The head just follows that, laying down tiny 0.2 millimeter layers of the material, and our material options in this case are PET, or sorry, PLA I should say, plastic and ABS components. Yeah, and you can pretty much have any of that sort of stuff for your showers or things at home. Yep, so custom parts and solutions for your home or RV. I put PET in there, I'm going to change it. Thanks for watching.